Hello everyone, welcome to Mission VTU YouTube channel. We are dealing with the model question paper number 1 of a 6th semester subject Embedded System Design. Here we are dealing with the module 3 5th A question. Explain monolithic and microkernels with a suitable example for each. B. Discuss the terms task, process and threads. And C. Three process with the process IDs P1, P2 and P3 with estimated completion time 10, 5, 7 milliseconds respectively. Enter the ready queue together in order P1, P2 and P3. Calculate waiting time and run around time for each process and average waiting time and TAT. Assume there is no IO input or output waiting for the processes. And here is the answer for 5th A. Monolithic kernel. Here all monolithic kernel services run in the kernel space. All kernel modules run within the same memory space under a single kernel thread. The tight internal integration of a kernel modules in a monolithic kernel architecture allows the effective utilization of the low-level features of underlying systems. Linux, Solaris is MS-DOS kernels are example of a monolithic kernel. Here, monolithic kernel with all operating system service running in kernel space will in and out the applications. And the next is a microkernel. The microkernel design incorporates only the essential sets of operating system service into the kernel. Rest of the operating system services are implemented in programs known as servers, which runs in the user space. The kernel design is highly modular, provides OS neutral abstraction. In memory management, the process management, timer system and interrupts handlers are example of essential services which forms the part of a microkernel. And the examples are QNX, Minix 3 kernels are examples of microkernels. Here the diagram you can refer in the exams. And here is the 5th B answer. Task, process and threads. In the operating system context, a task is defined as the program in execution and the related information maintained by the operating system for the program. The task is also known as a job in the operating system context. A program or a part of it is an execution is also called as a process. The term task, job and process refer to the same entity in the operating system context, and the most often they are used interchangeably. A process requires various system resources like a CPU for executing the process memory or storing of the code corresponding to the process and associated variables, IO input or output device for information exchange, etc. Next is the structure of a process. The concept of a process leads to the concurrent execution of tasks and thereby efficient utilization of the CPU and other system resources. Concurrent execution is achieved through the sharing of a CPU among the process. A process minimizes a process in properties and holds a set of registers process status, a program counter which is known as a PC, to the point to the next executable instruction of the process, a stack for holding the local variables associated with the process. A process which inherits all the properties of the CPU can be considered as a virtual processor, awaiting its turn to have its properties switched into the physical processes. When the process get its turn, its register and program counter register becomes mapped to the physical register of the CPU. Here is the block diagram you can refer in the exam. And the next is of a threads. A thread is the primitivity that can execute code. A thread is a single sequential flow of control within a process. Thread is also known as lightweighted process. A process can have many threads of execution, and different threads which are part of a processes which share the same address space, meaning they share the data memory, code memory, and heap memory area heap memory area. Threads maintain their own threads status in CPU register values and program counter and stack. Here is the diagram you can refer in the exam.